Have you ever wondered about the red line on your bike's tachometer? It's that red shading in the upper reaches of the gauge that you're not supposed to venture into. But why do engines have a rev ceiling? And why do some motorcycles have a low red line while other motorcycles have a high red line? Well, let's open up the shop manual and find out. Engines are kind of miraculous. I mean, there are so many parts spinning and reciprocating up and down between these cases. But turns out there's a limit to how fast things can move before bad stuff happens. Reciprocating engine parts like the piston and connecting rod have mass and thus inertia and momentum, which means they're going to resist changes in speed and direction. So the faster the engine revs, the harder the piston is going to try and fly off the wrist pin, and the more violently the connecting rod is going to try and tear itself away from the crank. And eventually, they will. The parts will fatigue, and the engine is going to turn to scrap. It might be hard to imagine robust metal parts just giving up and breaking, but consider this piston out of a CBR 600RR. At redline up near 15,000 RPM, it's accelerating from a dead stop at the bottom of the stroke up to nearly 75 miles per hour midway through the stroke, and then coming to a complete stop again at the top of the stroke. And it's doing all of that in just 4/1000ths of a second. That instantaneous acceleration creates a force of 1,700 Gs on this little piston. So while this thing only weighs about 4 ounces in my hand, when it's changing direction at redline, which it's doing 500 times per second, it develops a load of roughly 450 pounds. That's literally more than the entire CBR weighs. So with that in mind, you can kind of see how things might have a hard time staying together. So engines have a limit to how fast they can spin, because beyond a certain RPM, the effective weight of reciprocating parts will cause them to fatigue and break. And even if you lighten and strengthen bottom end parts to cope with the RPM, there are other areas of the engine where inertia is going to rear its ugly head, namely the valve train. In a 4-stroke engine, valves in the cylinder head control the flow of fuel and air into the cylinder and the flow of exhaust gases out. The valves are pushed open by the camshaft and closed by a spring. The pressure the spring exerts ensures that the valve always follows the cam's motion and returns to a closed position. If the engine is revved too high, however, the momentum of the valve train components may be too strong for the spring to overcome, so the valve's motion might not follow the cam's motion as it's closing. This is called valve float, and it's bad news, because if the valve hangs open long enough, it may make contact with the piston as it's rising in the cylinder, and you can imagine how that goes. So, valve float is another important reason why engines have red lines. Now, there are engines, like Ducati Desmodromic motors, that don't rely on valve springs. In a Desmo engine, a separate rocker arm forces the valve closed, so valve float isn't possible. And 2-stroke engines don't even have valves to float. And yet, both Desmo Ducatis and Ringding 2-strokes still have rev ceilings, because their other reciprocating parts can't escape the laws of physics. Alright, so that's why every engine, whether it's a 2-stroke or a 4-stroke, a Desmo or a conventional valve spring, has a rev ceiling. But you might be wondering, why do different bikes have different red lines? This Harley-Davidson Street Glide maxes out at just 5,500 RPM. Meanwhile, this Honda CBR 600R spins to over 15,000 RPM. Once again, it has to do with inertia. Going back to the issue of valve float, there are significant differences in the design of these two engines. The Honda is an overhead cam design. That means the cams are up in the cylinder head and operate directly on the valves. It's got fewer parts, so therefore less mass and less inertia to contend with, so the engine can spin faster before valve float is a concern. On the other hand, the Harley's pushrod valve train has more components. It's got tappets, pushrods, and rocker arms in addition to the valves and springs. That's a lot more mass to manage, so it limits the speed the engine can turn before valve float occurs. Then there's piston speed, which is proportional to piston stroke. The longer the stroke, the higher the maximum piston speed for a given engine RPM. So at redline, this Harley Street Glide's piston is maxing out at 64 miles per hour. Not that much slower than the 75 miles per hour we saw for the CBR up at 15,000 RPM. It's for this reason that sport bikes and other performance engines run a shorter stroke, so they can turn higher RPM and make more horsepower. There are other contributing factors to how fast an engine can spin, like intake and exhaust design, or even how fast gasoline can burn in the cylinder, but by and large, it's the inertia of reciprocating parts that determines the operating threshold for a given engine. If all of this has you worrying about accidentally blowing up your engine because you gave it too much gas, don't sweat it. Most modern bikes have a rev limiter that will cut the fuel or the ignition in order to keep the engine revs at a safe speed, and most manufacturers bake in quite a bit of margin. That being said, the rev limiter is there for your engine's safety, not as a party trick at stoplights and bike nights. So go ahead, enjoy the revs your engine has to offer, which is everything up to the red line. You just don't want to keep it spinning that high unnecessarily because it will wear your engine out faster.